Come again, Prof.
Please, sir, which application are you using to present?
I'm presenting using Zoom. We're on Zoom. You can see you are all logged into Zoom, and then my files and Explorer. So I hope that's what I hope this is what the questioner is trying to understand. I don't know. So we are in Zoom. In Zoom, I'm sharing my screen, and then I have Weka installed. Sometimes I share the Weka with you, and then I put my file in the PowerPoint presentation file by Microsoft. I think those are the system we are using presently. Yeah. I hope that is answered. So next.
Okay. What is the yardstick of dividing the data of to training sets and testing sets?
Training set to testing set. Well, it depends on what you want to do. Like I said, if you are solving a problem or a problem that someone earlier solved, let's pay attention to this. You are solving a problem that someone earlier solved. In that case, you need to use the same. You need to actually. You need to use the same partition method they used before. If they use 70-30, you cannot use 80-20 because you cannot compare your work with their work. And in machine learning, we do a lot of comparison, by the way. You want to see, are you getting better result than the previous guy? If someone got 95%, you want to see, can I get 99? Because this is a medical problem. You can pick up his data set, try to get better result. You can also publish that, by the way. You see? Because you are able to improve upon what has been done in literature. But then, in order to be fair to that person, if you use 80%, 20, you need to also use 80-20. However, if you want to use others, you can add more. You can also try, okay, I want to use 70-30 also. I want to use cross validation, n-fold, maybe 5-fold or 10-fold that we discussed today. But the one that you want to compare with, the original research work, you must use their own. But if you are the first one to work on this data, then you are at liberty to use whatever you like. In which case, I recommend 70-30 for you, 70% training, 30% testing. And if the data is much, divide into 3, 70 for training, 15 for validation, and then another 15 for testing. So depending on the case, sometimes you may need to consult experts to also provide guidance as you try to train this kind of profession. Thank you very much.
Question 3, if we have small data, like 15 sample, how many folds of cross-validation is ideal?
Thank you very much. So like only 15 samples, you can go for like maybe 2-fold should be fine, maximum 3-fold, but don't make it more. Like someone actually in the past submitted a paper and very few data, not 15, maybe 20 something or thereabout, but very few. He used 10-fold. One of the comments was that why using 10-fold when the data is small? You see, because when you divide 15 to 10 places, maybe you're going to have 1 in one of the folds, which is not good. So you divide it based on the number of data. 2-fold should be fine for this example, or 3-fold maximum. You have 5 in each of them. That will still be okay, but not more than 3. Yeah. Next,
for the slide on training and validation, if divided into 2, where are the testing data?
Where are the testing data? For the slide, I hope I'm getting you. Rod, doctor, can you come with that question again?
He said for the slide on training and validation.
Okay.
If divided into 2, where are the testing data?
Yeah, this is the testing data. I think you can see here. I think this is the screen someone is referring to. You divide the data into 2. This is training sets. You give it to your algorithm to build the model. Then the testing set is kept separate after the building the model. You can see to check if the model you have built is correct. So this is what we have done here. You have the training set and then you have the testing set. You divide your data appropriately, and we demonstrated that also in the Weka. That is, you tell the Weka 70 for training, Weaker will help you to divide into 2, 70, 30. And then run the experiment on the training and then give you the result of also the testing. So it is when you have three, when you have three partitions.
We have three. Okay.
Hello, doctor. Hold on. When you have three partitions, you have here, the data is here. So you have, there's going to be training set, validation set, then the testing is outside. You have three. But the previous, I think the questioner is talking about this one with only 2. Thank you. Next.
Okay, doctor, does that mean that if we have the partition into 2, we have only training and testing? He was asking about if we divide into 2, we have a training and validation.
Yeah.
What about the testing?
Okay, sorry, doctor. It's good to mention the question number, please, so that we can be able to track it.
Yeah, it's question number 4.
Okay. Question again, please. Question again.
I mean, the one just answered now. You answered. I said if we have 2 partitions, we have training and validation. Okay. What about the testing?
Okay, in the 2 partition, in that case, the testing is going to be is serving as both training, as serving as both testing and validation, because you don't have a provision for the validation separately. So the testing is actually what is happening is this. It's like, okay, I'm building my model. Let's look at this diagram. So hopefully we get it a little bit better here. Look at this diagram here. Yeah. For this one, we have very few data. We divided into 2. Even if your data is big, sometimes you might want to go for 2. That's fine. Majority of people don't have any issue with this. So when you build your data, you build your model using the training set, you take the testing set to check the model you have built. Is it working fine? The good thing is we didn't expose our testing set to the training, to the model during training. This is what we want to ensure. Make sure that your testing set is not used for training. Simple. You see, but if your data is big, because some people believe that, the people who have the opinion and they are very passionate of it. Some people, I call them like a kind of they are too much strict, unnecessary too strict on this. They want you to have these 3 partitions: training, validation, and testing. Yeah.
Okay, now question number 5.
Yeah.
What is the magnitude of the data set sample size before it can be considered to be big? Okay,
thank you very much. To answer the question, I just clarify a bit about the question 4, the way I was answering, that when you divide it into 3, you have the training and then the validation because the data is big, or because it's a requirement. Maybe someone by your some reviewers are very strict. They say, we want you to have different data for testing separated from validation, because they said that during training, when you train, you use this validation to check if it is good. If it is not good, you go and modify your algorithm and then do it again. They said because you are using that validation to check if it's good, if it's not good, you go and redo. In that case, they think that maybe your model is a little bit having an idea of the validation set. So they expect you to have a thought set that you are not going to use it to even check it at all. After everything is built, no more training, no more checking again. This is called the production testing. Once you do it, the client is going to have it. You see, this is why you have 3. So if you have opportunity for 3, I recommend 3. But if your data is not enough for 3, 2 is also okay. And we have a lot of publication where we have only 2 and there's no issue with it. And they have been published in Q1 journals and Q2. So there's no really issue. Either you use 2 partition or 3 partition, provided you follow the appropriate procedure. Now to the question 5, that says how big a data will be before we can consider it to be big. Am I right, doctor?
Yes, Prof.
Yeah, question 5. This is where the issue lies. Big data is a relative term. So how big it is, we cannot really specify the number, by the way. But however, as a rule of thumb, if you have data in the range of, let's say, like waste stock of 15 like that, using partitioning into 2 or 3 is not even going to arise. Cross-validation should do that for you, and 2-fold or 3-fold maximum. But when you have data in the range of 100, okay, then in that case, yeah, 70-30 can work, or 80-20. But when your because it's not more, but when your data is really going towards 500, 1,000, 500, 600, then you can think of using 3 partitioning, because it's not very big. Like I said, it's a relative term, by the way. Let me leave that one. Like I said, enough, the data that is enough for training is a relative term. Data enough in some feed. In some feed, you give them 100 samples to build. They work well. In some area, even 1,000 data, you struggle to build a reasonable model because of the nature of the data set itself. And also it depends on model. If your data is still 1,500, majority of the model will not work. But then I recommend a friend here, SVM, that says algorithm called support vector machine. You can see it on our YouTube. We already described it in 3 videos. Support vector machine has the capability of working for you when your data set is very few, 15, 20, 100. Where neural network, we expect you to have like more. Support vector machines still have a way of working fine. K-nearest neighbor also, a very simple classifier, can work for you. Now,
Prof, please, can we use Weka for optimizing, let's say, neural network for diagnosis?
Okay. Prof, can you use what? Can you use what? Question
Weka,
number what?
Weka.
Question
Number 6.
Number 6.
Number 6.
Okay.
Can we use Weka for optimizing, let's say, neural network for diagnosis?
Yeah, I think we have demonstrated that every neural network, support vector machine, any algorithm, decision tree, you can use Weka to do it. Virtually, there's hardly whatever you want to do in machine learning now that Weka couldn't provide for you. Like I said, previously it doesn't support deep learning, but now recently you have deep learning has been integrated into Weka. So it should be able to work for everybody.
Number 7.
Okay.
How do we calculate kappa coefficients after classification?
Okay, yeah. So like I said, it depends on the kind of work you are doing. You see, when you want to run, when you want to do a machine learning for a particular problem, you look at people working that area. What are they interested in? For example, in software engineering prediction, if you want to predict effort, there are some percentage measure based on percentage you want to see. Not the root mean square error is an addition, but they have some specific they are looking for. The same thing with this kappa ratio that you're talking about. There are some areas that they need you to use it. Weka has this capability. It will display everything for you. If it's not showing presently in where you are, just go to the option. We demonstrated it yesterday. You can check it in the video. You just go to options and select. There are a lot of quality measures that might not be there because there are so many quality measures. So you go inside Weka and try to select that particular kappa calculation you want to use, select it, Weka will bring it out as part of your results. Because Weka doesn't want to bring, Weka only deal with default what majority of people are using. But there's a lot of statistical measure you can use. You just go to the option, select it, and it will be available for you when you run your experiment. Thank you.
Number 8, how do we calculate variance accounted for after regression?
How will you calculate what?
Variance accounted for after regression.
How will you calculate variance accounted for after regression? Okay, yeah, well, when you have regression problem, the first thing you have to do is you check the correlation coefficient. How close are they? And the root mean square error. These two are very important. Of course, there are other measures you can use depending on the area you are working. Yeah. However, one of the things I really recommend for people is to plot the actual value your model is predicting, plot it side by side, the original one you are given. You can see how they are far away from each other. Visually, you can see either they are touching one another. Sometimes we have prediction that, mashallah, they are so accurate that the predicted value is standing on top of every actual value. And in some cases, you see very different. You can easily visualize and see how close they are. In addition to using all those statistical formulas, we want also for you to show visually that, okay, for example, after you did your prediction, this is actual value, this is actual, When I do the prediction is falling A. The second one is A, very close by. Some will be on top exactly, superimposing the old one. And then sometimes you're lying to connect it together. So we usually recommend you to use a kind of visual presentation to see how deviated from the actual value your model has actually displayed. I hope that clarifies.
Question 9, sir, can this ML be applied to social science studies, especially in the field of gender and development studies?
Yeah, like, thank you very much for the question. Look to say, these days, I spoke with someone this afternoon. So it used to be one of the person that who had interest in this. I asked some question. I said, virtually any area we have, if you can have data, just get the data, machine learning will be able to do something for you. You can just see example mentioned yesterday by our coordinator, admin, Dr. Tijani Akpalara. For example of how they use AI to detect someone in the shopping mall who is having problem that the parents are not even aware of. You see, this is machine learning. Just get the data. There are a lot of possibilities. In fact, social science area are area that I think people actually need it these days, actually. A lot of area we want to, okay, as a psychologist, you want to be able to detect if your student is getting closer to having a psychological problem. Depression. Some of them are looking medical. Depression is more of psychology than just even the really medical, actually. So there are so many areas we want to look at people, like some of the challenges in the society, it is the data. And often these data are lying fallow, wasting away because we don't utilize it, actually. And this is one of the essence of this kind of summer training. We want people to really start thinking that there is a technology that is really going far. We have to catch up. A lot of people are really going ahead. So many things are being done already in machine learning, either social, whatever area. So like our coordinator already said, for those that are really interested in pushing forward, and I advise, we can join our weekly program because 3 days is not enough to expose us to machine learning. We just try our best to at least expose to us as much as possible. But definitely any area we can get data, we can make questionnaire. Any area where we can make questionnaire, for sure, we can definitely do something about machine learning. Once you can make a questionnaire with data gotten from that questionnaire, machine learning can work for you. Thank you.
Number 10, sir, does this cross-fold method not exposing our testing sample to the model already?
Okay. Thank you very much for that question. I like that. The idea is that cross-validation, is trying to, they want to see, they call it proof of concept. In fact, by the way, there are some research houses like Jonah that will not take if you don't use cross-validation, but very few. That's why I'll usually tell my students, you can put 70%, 30% one side, and also do cross-validation by side. Anyone they want, they can get it there appropriately. You see? So because sometimes the essence of cross-validation is we want to see, let us see that together. We want to see how, that's why we call it proof of concept. If you want to deploy it for your client, you cannot use it. This is the fact. We can't deploy cross-validation for our client. Let's say a client wants to use it to predict in the company, they're going to save it and use it for prediction. You need to develop using holdout. They give you big data, you divide the data into like 70, use 15% to check if it's correct, use another 15% to check, you check many times, then you can deploy for your client because you don't want a disappointment. However, especially when we have few data sets, like a new area in material science, we got only 15 samples. You cannot deploy it with just 15 samples, you need more. But we need a proof of concept to show that we can use machine learning in this area. So we want to see that, okay, if we use this for testing, how is it behaving? If you use this for testing, how is it behaving? We're going to find the average finally. And the average is like 97. This is an indication that, yes, that means we can do something in this area. It's proving that, this data is relevant. We can really use machine learning to solve this problem. You see, Because when we divide into 2 only, 70, 30, somebody will say that what these 30 have never been used for training, they might be affecting the outcome. If we use this 30 to become training and 70 for testing, maybe the result will be different. Some people will argue like this. This is why people use cross-validation to prevent this kind of argument. However, when the data is few, you don't have option, you have to use this cross-validation because division into 2 is not even possible. However, when the data become more, then we go for division into 3, which is the best, or you divide into 2, which is also good. Thank you very much.
This is number 11 now, but I think, okay, let me read it first. Please, I just tried to access the diabetes data set through the provided link via WhatsApp, and the site said the data set doesn't appear to exist. Okay, in that, maybe I'm going to repost that again. I don't think that is any.
Well,
number 12. I think, okay, yes, it's there now, this data set now. Or you can post again in the forum. Number 12, how do I install the Wika as you explain on the screen? I don't know what you click that bring the screen. I missed yesterday's class actually.
Well,
maybe it refers to the video.
Yeah, because of our time, I think we will have to refer the questioner to the videos that will be posted for us. We already also have video on how to explore Wika using how to use Excel file in Wika. You can see it in our websites, in our YouTube, and also our website as the case may be. So because of time and how many questions have we taken the coordinator? I think it's time for us to call it today. Which number did we take last?
13.
Okay.
No, the last one is 12. I start from the last question, 12, but it's 13.
Okay.
It remains about 8 questions. We have 22 questions. We have answered 14.
Okay.
Maybe we should stop and then continue through the video. I can answer the question and send to us.
Okay. Okay. So like we said, so definitely we are going to answer all the questions later, and we're going to upload them to our YouTube channels. So, and then once again, we got lots of, so we got a couple of, maybe we got a request that this is going to be the end of the question section because the time is over. We really thank you for the patience and the cooperation throughout the time. And then like I said, we encourage you all to have a look. The essence of the program is to expose us of machine learning, but 1 week is not enough, not to talk of 3 days. So we hope we can have continuous connections together. So through collaborations and trying to see those that I find it really interesting. And I want to believe with some feedbacks, majority of us are finding the area interesting for us to follow. There will be other future engagements, especially for our youth, some of the job opportunities, undergraduates, graduate students. So some of the job opportunity, maybe there will be another opportunity for talking about career opportunity in AI and data science. For the researchers, university professor, thank you all for the feedbacks and also the time.